Good afternoon to all. Any doubt in last class? No. Okay. If you have any doubt, immediately you ask me. No problem. Okay. But okay, listen. Now we are going to discuss about degrees and radians. Degrees and radians. Okay, already you have studied about degree and radian in mathematics in lower classes like 6th, 7th, 8th standard. I am correct or not? Okay. Here, what is mean by degree? What is mean by radian? Okay. In measuring angles, there are several possible units are used. That means different units are used to measuring angles. But commonly used two units to measuring angles, that is called degrees and radians. Okay. Okay. Degree, that means 2 degree, 3 degree, 4 degree, like that. But now we are going to discuss about mainly what is meant by radian. Okay. What is meant by radian? Okay. Listen. This is one circle. Center of the circle. That is called theta. Okay, listen. Okay. Radian means, radian describes a planar angle by the circular arc at the center of the circle. Okay, that means the planar angle subtended by the circular arc at the center of circle. Okay. What is meant by radian? This is an angle on the plane, so that is called a planar angle. Okay. Subtended by circular arc at the center of circle. Okay. But at the same time, radian is defined as, radian is not one radian, generally radian. Keep in your mind. Radian, it is defined as the length of the circular arc divided by radius of the arc. That's all. Radian, it is defined as length of the circular arc divided by radius of the circular arc. This is radius of the circular arc. Okay, it is called generally radian. Okay, then what is meant by 1 radian? Radian that is different, 1 radian that is different. One radian. Okay. Listen. See this diagram. 1 radian, it is defined as the angle subtended by the circular arc at the center of the circle. Okay, the angle subtended by circular arc at the center of the circle, that is equal in length to the radius of the circle. That's all. Clear or not? If length of the circular arc, it is equal to radius of the circle Now this angle is equal to 1 radian. Clear? That means this length, it is equal to this length. It is simply represented in your textbook as a yellow color. Take and see. Come on. This gap. This gap. This length. It is equal to this. Length of the circular arc equal to, this is center of the circle. It is equal to radius of the circle. Now this theta is equal to 1 radian or 1 rad. Radian or rad. Clear? Okay. This is about 1 radian. Clear? Okay. Very simple topic, nothing else. Listen properly. Now, suppose let us consider one particle or an object, or taking one stone, any one object revolving around this, that means around this point. Okay? Around this point, that is called the center of the circle. Let us consider one particle revolving around this point. So, what is the position of the particle or an object at the time t is equal to 0? This point. I am correct or not? That means in starting. Clear? Okay. What is the angle here at this point? Very good. Yourself correct. 0 degree. 0 degree. Okay. Then, now time t is equal to t second. What is t or t second? We don't know. 2 seconds or 3 seconds or 5 seconds. Time t is equal to t second. Suppose at t second, this particles just moves like this and reached this point. Now, here theta is equal to 0 degree. At this point, when reached this point, the particle, right angle, no? Very good. So here, theta is equal to 90 degree. That is called a right angle. Like this. I am correct or not? Right angle. It is equal to 90 degree. Okay? Then, when reached this point, theta is equal to, very good, 180 degree. Theta is equal to 180 degree. At this point, 270 degree. At the same time here, 360 degree. That's all. So for one complete circle, theta will be very good. 360 degree for complete circle. Okay? Okay. In radian here, very good, pi by 2 radian. Here, very good, straight angle, that is equal to pi radian. I am correct or not? Here, okay, 270 degree. At this point here, 2 pi radian. This is pi by 2. 1 half, second half. At this point, complete one circle, it is equal to 360 degree or in radian 2 pi radian. Very good. So, 360 degree is equal to 2 pi radian. 2 pi radians. Alright. Okay. Then R 2 pi radians is equal to 360 degree. Okay. 2 pi into 1 radian is equal to 2 pi radian, that's all. Am I correct or not? Or 1 radian is equal to, how? This term we can split it as 2 pi into 1 radian, am I correct or not? 2 pi into 1 radian, okay? For 1 radian, by, that's all, 360 degree by 2 pi. Okay? Therefore, simple. 1 radian or rad is equal to okay, 180 degree by pi. Clear? Or pi is equal to 22 by 7 or 3.14. 3.14. So 1 radian is equal to 180 degree by 3.14 is equal to 57 point, come on, divide it quick. 180 by 3.14, come on, how much? Very good, 57.29 or 3 degree. So very, very important. 1 radian is equal to 57.3 degree, that's all. Okay, come on, see, read out. This is very, very, very important. 1 radian is equal to 57.3 degree. It is used for solving 1 mark problems. Okay, so memory it. That point only. Last point. This one. Very important. Okay. Then, based on this topic, now we are going to discuss about one very, very important example problem. Okay, listen. Example problem 2.39. Take your textbook. Page number 88. Simplest problem this. Okay, come on, read. Calculate the angle theta subtended by 2 adjacent wooden spokes. Adjacent. It is adjacent. In Tamil, adutaduthu. Continuously. Okay. For example, like this. 4 chalk pieces are there. Okay. What is adjacent? The gap between adjacent chalk piece, come and tell me. This gap, okay? No. That is wrong. This gap is correct. Correct? Huh? Adjacent means adutaduthu, continuously. R will be this gap. R will be this gap, okay? Yeah. That is called angle between adjacent chalk pieces. Okay? Wooden spokes of a bullet cart. In Tamil? Yes. Maatun in Sotamal, yeah. Bullet cart. Wheel is shown in the figure. Okay. Here, express the angle in both radian and degrees. Okay? Come on, take your book. How many wooden spokes in the wheel? Mattundi. Okay? How many spokes? Come on, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I think. I am right or not? Okay. Here we should be find out this value. Okay? 2 adjacent, for example, this 2 adjacent wooden spokes. For example, let us consider these 2 spokes. Okay? Denoted in different color in your textbook. See your textbook. Okay. What will be theta value? You should be find out theta value in both radian and degrees. Okay? So, how? Very simple. Very simple. You can say mentally. Okay? Theta is equal to what? How many spokes are there? 12 spokes. Incomplete. Okay? So, incomplete wheel, that is called like circle. I am correct or not? This is example for circle. So, 12 spokes. I am correct or not? How many spokes are there? 12 spokes. Okay? So, 12 spokes, it is equal to one complete circle. That means that this one wheel contains 12 spokes. Okay? So, 12 spokes is equal to how much in degree? Very good. 360 degree or 2 pi radians. Am I correct? Yes. So, for one part, very good. Divided by 12, that's all. Very simple. So, theta is equal to 2 pi radian by 12. 2 pi radian is equal to 12 spokes. That means it is equal to complete circle. I am correct or not? It is equal to 360 degree. How many spokes are there? 12. I am correct or not? So for one part, angle between two adjacent. I am correct or not? That means for one angle of one part, this is equal to 2 pi by how many spokes? So you must divide it by number of spokes in the wheel. How much? 12. How many spokes? 12. That's all. So pi by 6 radian. Clear? In radian. Okay. Very good. Next, come on. Anyone, known person, try yourself quick. Yourself. In degree. Very good. Because pi radian is equal to, very good, 180 degree. Pi radian is equal to 180 degree. So 180 by 6 is equal to 30 degree. Very good. Yourself correct. You are correct. 30 degree. Okay. This is equal to 30 degree. It is correct or wrong? Come and check. How do you check it? Correct or wrong? Yes. How many spokes are there? 12. 12 is equal to for one complete wheel. I am correct or not? Sorry, for one complete circle. It is equal to like wheel. I am correct or not? So for one part, this gap is equal to 30 degree. How many spokes are there? 12. 12 into 30, 360. So complete circle. That's all. So answer is correct. So 30 degree. How many spokes? 12. 3 12s are 36 for 0. So it is correct. Okay? This value is equal to correct. So the angle theta subtended by two adjacent wooden spokes, it is equal to 30 degree. In radian, pi by 6 radian. That's all. Clear? Any doubt? Very simple. Clear? Okay. Next we are going to discuss about separate topic. Angular displacement, angular velocity and angular acceleration. Okay? Okay. Listen. Now we are going to discuss about three main topics. This is basic. Okay? First one is angular displacement. Second one is nothing else, very simplest topic this. Angular velocity. Symbol for this theta. Symbol for angular velocity omega. That is very, very important. This is simply denoted by theta. This is denoted by omega. And angular acceleration. This is alpha. Okay. This vector quantity no need, only enough symbol. Theta, omega, alpha. Okay, first. Angular displacement. Angular displacement. Okay. Listen here. This is circle. Center of the circle. B. This is A. This is S or theta. Okay, listen. Already seen this about this diagram. Okay. What is 1 radian? Okay. If length of the arc, I am correct or not? Circular arc is equal to radius of the circle. Now this theta is equal to 1 radian. Okay. This gap and this gap, it is equal to R. That means the same. Okay. Now, angular displacement. Already you have studied about linear displacement. Okay. Linear velocity. Okay. Linear acceleration. I am correct or not? That's all. The difference between angular and linear only 1 point. In linear, straightly. That's all. In angular, theta. That's all. Okay. What is the displacement generally? That means the displacement or linear displacement. But angular displacement, that is different. What is the displacement? Change of position of the particle with respect to time. Okay. That is called here. I am standing here. Time is equal to 0. Starting. Just I am starting to walk like this. Okay. I covered this point from that point. So this gap. With respect to time, no, that is called linear displacement. Okay. Similarly, let us consider a particle traveling along a circular path around the point O or about the axis of the circle. Okay. Just consider here. At a time t is equal to 0, what is the position of the particle? Very good, point A. At this point, starting point. Okay, now time is equal to 0. Now, take stop clock on it. Like this, I am correct or not? So it is rotating. That means our time is starting. So at time t is equal to t second, let us consider position of the particle B. Okay. Position of the particle B, like this. So, like this. So particles moves along circular path, traveling along circular path. I am correct or not? From here to here. That gap, it is equal to S. Okay. So the particle described or angle described by the particle at the center of the circle. At the center of the circle, at point O, in a given time, that's all. Okay, that is called angular displacement. That means the angle described by the particle in a given time. That's all. That is called angular displacement. Okay, so theta is equal to S by R. This is the formula for angular displacement. Okay, this is the radius of the circle R. S is equal to theta into R. Okay? That's all. Then, angular displacement, okay. Then what is meant by angular velocity? Simple, nothing else. Already discussed about linear velocity. Come on, tell me what is linear velocity? Very good. You are correct. Rate of change of displacement. Very good. Or change in displacement with respect to time. That's all. That is called velocity or linear velocity. Okay, just one word changes here. Rate of change of, very good, angular displacement, that is called angular velocity. That's all. Okay. Second, listen. Angular velocity. Its symbol omega. Okay, listen. This is center of the circle. This is radius of the circle. Your particles start like this. This is linear velocity direction. Okay, it is changes. And this point like this. And this point like this. Yeah, let us consider one particle revolving around this point O in circular path. Okay, in anti-clockwise direction. In anti-clockwise direction. Okay. So definition: rate of change of very good, angular displacement is called angular velocity. So what is the rate of change of angular displacement? What is the angular displacement? Theta, no? So change in displacement, change in angular displacement, d theta. With respect to time, change in time, dt. That's all. Basic formula: omega c is equal to d theta by dt, or simply written as theta by t, or theta is equal to omega t. Very, very important formulas. Very, very important formulas. Okay? Okay. How do you find out the direction of the angular velocity? Very good, with the help of right hand. Let us consider here for this diagram direction of the angular velocity through the axis of the rotation. That is important. For example, and one particle revolving like this or rotating like this. Okay? One particle, let's consider one particle rotating like this. Take a top bumper rotating like this about an axis. What will be direction of the angular velocity with the help of right hand rule? This four fingers denotes direction of the rotation of the object from here. Yeah. So this gives direction of the rotation of the object like this. The stretched thumb denotes direction of the very good angular velocity through the axis of the rotation. That's all. Suppose the same top bumper, if this is like this, rotating like this. Now direction of the angular velocity downwards. That's all with the help of this rule. This finger denotes direction of the rotation of the particle. This finger denotes direction of the angular velocity. That's all. Clear? Okay. Clear? Then, simplest next. Third one. Okay, you can say directly, simple. What is a linear acceleration? Very good. Rate of change of velocity, that's all. Or rate of change of linear velocity, that's all. Basic formula. V is equal to displacement by time. I am correct or not? This is for velocity. Acceleration, linear acceleration A, V by T. I am correct or not? Similarly, instead of A, here you must write alpha. That's all. So, angular acceleration, rate of change of angular velocity, that is called angular acceleration. That's all. So formula. V omega V. That's all. Okay. Rate of change of angular velocity, that is called angular acceleration. Okay. Then we are going to discuss about units. That is very, very important. No? What is the unit of angular displacement? I told you. Very good. Radian. Or rad. Okay. Unit of angular displacement. Okay. Unit of angular velocity. You can write with the help of formula. No? So omega is equal to formula for this omega theta by t. Okay. So a theta radian for time second. So radian per second. That is the unit for angular velocity. Okay, come on, write ourselves. What will be unit for angular acceleration? Very simple. Yeah, radian per second. Already t here, change in time. You can only say a second. So radian per second square. That is the unit for angular acceleration. That's all. Clear? Come on, see. Any doubt? Come on, see. Any doubt? See fully. Okay, clear? See fully from here to there. Okay? Clear? Any doubt? Okay. Next, we are going to discuss about one problem based on this topic. Okay, listen. Yeah, see this problem. Very, very simple problem. Just try yourself. Okay. If Earth completes one revolution, complete a revolution in 24 hours, 24 மணி நேரத்துல ஒரு ரொட்டேஷனை கம்ப்ளீட் ஒரு ரெவல்யூஷனை கம்ப்ளீட் பண்ணுது. ஓகே. What is the angular displacement made by the earth in 1 hour? 1 hourல இருக்கிற angular displacement. So angular displacement, what is the angular displacement in 1 hour? Within 24 hours. Totally 24 hours. So read thoroughly. That is important. If the earth completes one revolution in 24 hours, what is the angular displacement made by earth in 1 hour? Express your answer in both radian and degree. Very simple. Okay, come on. Solution. Any idea? Very good. You are correct. Clear. 24 hours is equal to one revolution. I am correct or not? So for complete revolution, angle, very good, is equal to 2 pi radian or 360 degree. Very good. For 1 hour by 24, that's all. Already discussed one problem like this. I am correct or not? That's all. For 1 hour is equal to, in first in radian, 2 pi by 24. That's all. 2 pi radian by 24. Okay. So come on. What is the answer? Okay, that's all. So for 1 hour, angular displacement, that is theta, is equal to pi by 12 radian. Okay, pi by 12 radian. In radian. Okay, in degree, that's all very good. In degrees, this is in radian. In degrees, for 1 hour, angular displacement, pi radian is equal to 180 degree. So 180 degree by 12 is equal to, come on, how much? Very good. 15 degree in degrees. That's all clear. Any doubt? Any doubt? Come on, see again. Why did that, sir? Clear? See fully. Okay, thank you.